Yeah, we're good to go. Last session, the July Central College, Hillard Powers. Several of you know Hillard already. He's our regional manager. He supports half of our authorized Draeger area. And I know several of you that are in attendance have been able to go over the past several years down to Houston and to Las Vegas for some of the national sales meetings. And for those of you who have not attended recently, there's a product that I asked Hillard to kind of look at in particular was the regard control system, and he's going to kind of go through that. I think you'll find some interesting
that solves the. So, like I mentioned, it's by far the most reliable gas detection controller ever developed, and the main reason why it's fundamentally different gas detection control than anything else out there. And the main reason why is we have no single point of failure. That means to be a buzzword, a catchword all our sales guys need to be using when we're going out there talking about this thing. On your traditional controllers, you have basically a master board that basically controls all the functions of that controller. So if something would happen to that board, you've lost your controller. So when Draeger was developing this product, we said, we don't want that to happen. We don't want to have one single point. If it fails, kills the whole system. So at Draeger, we developed a system with no single point of failure, right? And how do we get to that? Well, basically we use independent modules versus circuit boards. And each of these modules is smart, it has its own onboard CPU. And the type of modules, we'll go in a little bit of detail in the next couple of slides, but we've got 4 to 20 input modules. We've got relay output modules. We've got bridge modules that allow you to connect legacy regard systems to this new regard 7000. So we have all these different modules. And so in the design of the system, if you lose one of those modules, you basically just lost either the inputs or the outputs from that module to that module, but you haven't lost the whole safety system. So by safety system, what am I talking about? I'm talking about the modules and the visualization of that system. So even if you lose a module, you haven't lost your whole system. Another very key design feature, it's also a masterless system. So when you first plug this thing in, no matter how many modules it's got, the system will select a master that basically kind of controls the function of the whole system. In a good bit of detail, but it's constantly scanning to make sure that whatever the ranges are at the detectors are also what the controller is seeing, so you don't have an unsafe situation. And so with our system, you can have up to 1,536 input and output combinations. So basically you can have a regard system with up to 8 docking stations and 8 modules per docking station. You can have a really big controller, but so it's almost infinite basically with 1,500 inputs and outputs. And what I like to tell folks is that it's the last gas detection controller you'll ever have to purchase, because we made it expandable and alterable with firmware upgrades for additional functionality. So I don't know if you guys can see it, but next to the docking station on the bottom of the screen of the regard 7000, this little white little slot, that's actually a USB port. So as we come up with new modules, or maybe potentially have to tweak a module to make it a better performing unit, then we actually can go back and do firmware upgrades. So once you buy a regard system, you can expand it, you can change it all through firmware upgrades. You don't have to scrap your regard controller and buy another one. And so that's a nice feature. So we talked about just on the last slide, the detector controller mismatching possibilities. So this is how that could happen. So let's say that you call Don Johns down in Mobiles. Hey Don, I need an ammonia transmitter. He goes, okay, I sell Draeger and I love selling Draeger. So basically I'm gonna sell you one of our Polytron 8100s with an ammonia sensor. And they says, well, we need that thing to be 0 to 100 ppm range. So, oh yeah, no problem. You can do that. Just set the range at 100 ppm, you're good to go. So you buy the detector and the sensor and you range it to 0 to 100 ppm. So you go to the old style controller, which is in this example a Draeger Guard Plus, right? And so you set the controller up to basically read the same thing. So you tell the controller, hey, when you see 20 milliamps from the detector, that actually corresponds to a value of 100 ppm. So at the controller, you set your alarms. You set your alarm at A1 of 20 ppm and an A2 of 50 ppm. At A1 20 ppm, actually what the controller is actually seeing is the transmitter sending out 7.2 milliamps, which is the range, which with 20 ppm value corresponds to when you do a range of 100 ppm. You set your A2 at 50 ppm, which is basically 12 milliamps coming out of the transmitter. So everything's all hunky-dory, everything's great. Then all of a sudden, lightning strikes, or something happens to the transmitter, and you lose your transmitter. So you call Don Johns down in Mobile. Hey, Don, lightning hit my transmitter. I need a new transmitter. So we get you a new transmitter. And what comes from the factory is that transmitter, and but with the range is defaulted for that sensor being 0 to 300 ppm. Now we've got a problem because we forgot to go back to and change the range on the transmitter to be 0 to 100. So guess what? Now when you send out basically when the transmitter sees 20 ppm, for that range of 0 to 300, it's only going to send out 5.07 milliamps. It's only going to send out, if it gets to A2, 50 ppm of 6.67 milliamps. Guess what, guys? That controller at those milliamp values is not even going to set the A1 alarm off. That's a very unsafe situation. I know I've been selling instrumentation for the last 10 years, and I don't know how many times I got that phone call from that customer. Hey, man, I just bought that new transmitter from you, and the damn thing, I'm putting 50 ppm ammonia on there. The controller's only saying I'm seeing 25. Well, that's what happened, is they didn't change the range on the transmitter when they got it in. They just left it as the factory defaults. That's a very unsafe situation. So how does that apply to the Regard 7000? So what the Regard 7000 is constantly doing is scanning that transmission from the transmitter to controller to make sure there's no mismatches. That's one of the ways we've increased the reliability of our operation. So we overcome that potential mistake that I've seen plenty of times in the past. And if you guys have been selling gas detection in the past, you've seen it probably too. So more on the product concept. So like I mentioned, we talked about independent modules. So that's basically what you see there. And basically those independent modules actually fit into either an 8-slot docking station, or we now have available just a simple 4-slot docking station, right? So those, basically that's the picture there you see is basically how they slap together. Basically put the modules in there into the docking station. And ultimately that information from those modules is fed to the visualization of that system so you can see what's going on with it. So let's talk just a few minutes about the components of the Regard 7000 system. I could just talk about, we have the 8-slot docking station, we have a 4-slot docking station. We have different ways that you can visualize the information coming out of the Regard 7000. We have 2 main options. We have basically a dashboard, which is basically a touchscreen HMI, or also what we call a panel PC. So if you've been through eList and looked and seen what's available to quote from Regard 7000 as far as our pre-configured options, you see either panel PC or dashboard. And we'll go into detail on what the differences are between those two in a minute. Also we have carrier pins where you actually land your wires for that module. What's really nice design feature of the Regard 7000 is these carrier pins can either go above or below the docking station, depending on accessibility and ease of use, what the contractor wants to put in there, or the plant wants to put in there. Well, what most folks will do, they'll actually put all their pin carriers for the inputs on top and put all their outputs for the modules on the bottom to kind of keep them separated. But some of the flexibility you get with the Regard 7000. So some of the different modules we have available on the bottom, we have, like I mentioned, we have a 4 to 20 input module, both regular and HART. We have a relay module, both regular and complex. We have a digital input module. We have bridge modules, which would allow you to basically connect legacy old Regard systems to the new Regard 7000. And how you do that is through one of these bridge modules. We have long distance gateways that allow you to connect up to, I think, 30 kilometers away through fiber optic cable, different Regard systems into a central Regard 7000. And we also have Modbus gateway sets for Modbus inputs and Modbus outputs as well. And that's very important for the networking stuff we can do with this guy. So like I mentioned, we have long distance gateways, so you can connect. I think it's up to 6 remote Regard 7000 systems all into one central Regard 7000 that the customer can look at. So basically they can see what's going on with all the other Regard systems, but just log into that one that's in the center. And that computer screen right there is actually what Polysoft Software looks like if you had it installed on your computer. So I want to highlight that. We're going to talk a good bit about Polysoft later on. So let's talk about the go-to for most of these applications, which is going to be our 4 to 20 HART input module. We do it, like I mentioned, we have a regular 4 to 20 input module, but for the most part, you just want to use the HART one because it a lot of the features that kind of go away if you just have just a straight 4 to 20 from the transmitter to the controller. Once you have the heart, you get all the diagnostics you can pick up as well. So most time we're going to go with the heart module. Up to 8 input channels you can put on one module. And you have up to 8 different alarm thresholds per input channel. So potentially on one input channel, you can have 64 different alarm set points on that one input module. We have 8 different analog special signals that are configurable. So what is an analog special signal? So this is the diagnostic stuff that's available. So basically, if you have some sort of sensor fault or IR beam block or some fault that's going on with the transmitter or the sensor that's attached to that transmitter, basically the milliamps will drop below 4. So maybe beam block means 3 milliamps, or a sensor is not connected is 1.5 milliamps. But you have up to 8 special signals that you configure per module. There's also clear interpretation of those analog special signals. So basically we put a little deadband around, say, that 3 milliamp value, just to make absolutely sure that if we're going to try to send out 3 milliamps from the detector, which means basically beam block fault, that actually fault is picked up at the Regard 7000. We also have adjustable alarm suppression time for the modules. So basically, we want to make dang sure that sensor is actually in alarm before we actually will trip an actual alarm. This is part of the reliability of the system. And the next slide I'm going to show you really hammers this home. And basically, it's compatible with every 4 to 20 gas detection transmitter from Draeger or basically anybody else. So you can connect other people's stuff to the Regard 7000 via the 4 to 20 as well. So this is basically a little graph or chart of what gas detection could look like if you plotted it, have the milliamp values changing over time. So your first little hump there, that could be gas detection. That spiky thing, that first spiky thing down, that's probably a fault of some kind. That little small incline, that's basically as far as gas detection. That big spiky thing, that's probably not gas. So basically for that first little spiky thing down, like I mentioned, we put a little tolerance around that special signal because that's fallen below 4 milliamps. So we'll basically say at 2 milliamps plus or minus 10%. So 2 milliamps to 2.2 or 1.8, we're going to make sure that we're tripping that fault. Because let's say, for example, that these milliamp runs, they could be pretty long. And if anything happens, it's just a milliamp signal traveling from the transmitter to the controller. So if you have a big piece of equipment kick on, or something happens and it causes some electrical interference, you could basically cause a false alarm or not actually get to the fault set point that you need to in order for the controller to say, I'm actually in fault. So we put a little deadband around it to make sure that the fault signal is actually hit. So that next little big spiky thing is basically what I would consider is not gas. So when gas comes in proximity with basically any of our sensors, it takes a little while for the transmitter to actually pick that up as actual gas. So those are the rounded curves that you see on that chart there. This big spiky thing, that's not gas. But on traditional controllers, they will call that gas. And that's some of the problems that traditional controllers have is we basically said, okay, if you see 12 milliamps, Mr. Controller, trip that alarm. Doesn't matter if he sees it for 1 second or 5 seconds or 10 seconds. And that's basically what you're seeing is basically about 1 second it spiked up there. Well, that can't be gas. Because like I said, it takes a little bit of time for the transmitter and the sensor to actually read that gas and actually once the gas dissipates to go back out and actually start reading back down to the 4 milliamp value. So with the Regard 7000, with that adjustable alarm suppression time, we can actually make sure that's actually that the sensor is actually in alarm before we actually will trip that alarm contact. Now that feature of actually the adjustable alarm suppression, you can actually program that into a PLC, or you can program the DCS to do that. The big difference from the Regard 7000 is that's configurable and not have to be programmed. A lot of your big companies with big DCS systems have people on staff all the time that are there to actually make those changes to the DCS system, add those special features to it. That's someone you got to pay all the time, you got to keep on staff. Or if it's basically we're competing with a safety PLC, you can program that feature in there, but guess what? The guy who programmed it goes away 3 years later, you want to put a little alarm suppression on that detection point, and now you've got to call somebody in, you got to pay some engineer to come in and reprogram that PLC, versus if you had the ReGuard 7000, you basically just go in there and you can configure that option versus having to program it. It's a big difference in user ease of use for our system versus actually using PLCs or DCS systems. So we eliminate that and reduce the number of false gas alarms. So next I want to talk about the relay module. And like I mentioned, we have regular relay modules and complex relay modules. So basically each one of them has 8 changes over contacts per module. That means each module will have 8 different relay contacts that you can trip. All the contacts are SIL2 capable. Allows combination of gas alarm and special signals in one evaluation. And that's the big difference between the regular relay module and the complex. This is a situation that's happened. That's why we developed the complex relay module. Let's say that you have 4 different points, and you want to make sure that each of those points is in alarm before you'll trip some mitigation action. Either you're turning on a fan or opening an overhead door or some big action that you're taking based on all 4 of those points going into alarm. Let's say that you have a situation where you've got one of the sensors that you attached to that relay module goes into fault, but the other 3 go into alarm. Well, guess what? On traditional controllers, because all 4 points aren't actually in alarm, you're not turning on that big mitigation activity or whatever you decided to do if all 4 points go into alarm. That's when you use the complex relay modules, because it basically can set it up to say if that point goes into fault or alarm, you can basically trip the alarm at that point. So that's some of the extra reliability that we've built into the ReGuard 7000 through some of these modules. And we can also, there's actual adjustable activation delay time from 1 second to 100 minutes for those alarms. So let's say for the same example, you wanted all 4 of those points to go into alarm for a certain amount of time before you actually strip that big mitigation step. Well, you can configure that with a ReGuard 7000 versus having to program that feature into a DCS system or a safety PLC. That's some of the differences. So next I want to talk about the differences between actually, us talking to a ReGuard 7000 system versus actually going straight back to a PLC or DCS. So, so these are our different transmitters that basically we'll be talking straight to a PLC or DCS. Like I mentioned, there's issues. If you wanted to add an additional point, you'd actually have to make sure you have enough room, make sure you have a 420 input card on that DCS or that PLC, make sure you have enough room, and you have to go and program that new input in the future. It's going to be very costly and time consuming. Different transmitter types require different programming. Even the Draeger stuff. So those special signals I was talking about before, 3 milliamps means this, 2 milliamps means that. Each one of our transmitters has different special signals based on the type of transmitter that it is. So it would be very time consuming for someone who's not familiar with our stuff. Basically, I'd have to understand how to do that, look in a manual, go and program those special signals into the PLC or DCS. Like I mentioned, special signal tricky to implement, multiple analog input channels are required, and basically waste the smartness of the transmitter. So flip to the other example, which is basically having those different transmitters talk to ReGuard 7000 first, and then go into the DCS or the PLC. So like I mentioned, so those special signals, if it's a Draeger device, already pre-programmed in. So when you're configuring the ReGuard 7000, you say I'm hooking up a Polytron 8700 334 type sensor. All those special signals are already pre-programmed and just come on over. If you needed to add an extra point, it's very simple. You just hook the point onto the extra module or spot on one of those modules, and you configure that versus having to program it. Configuring is it's just drop-down menus, pulling it, hitting drop-down menus versus having to actually spend time in programming the DCS, the PLC to take that new input. And that's basically what we're competing with ReGuard 7000. That's who we're competing with. We're competing with a customer who wants to take all these signals back to their DCS, or they want to take it to a safety PLC or another type of PLC. That's really what we're competing with the ReGuard 7000. Because basically it's a PLC designed for gas detection, but it's so much easier to use because of be able to configure all those new inputs versus having to program them. And as far as the signal that goes from the ReGuard 7000 to their PLC or DCS, they would still be able to see all those values at their PLC or DCS through the Modbus TCP/IP output, but they'd be read-only, and actually any changing of the information needs to happen at the ReGuard 7000. Okay, So next I want to talk about a little about the visualization of the systems, the different options we have to view what's happening with that safety system. So like I mentioned, the advanced dashboard, we have two different types, well actually three different types, but these are the main ones we're going to offer. Is basically the touchscreen HMI, which basically mounts in front of a panel, or you can basically have the 19-inch rack 6RU version, which you would mount on top of an enclosure of some type. So what can the dashboard do? All the configurations can be done right there through the touch screen, or it can be, you can basically upload the configurations that you want on basically a USB stick, and then you can go up to the device and plug in that USB stick, that front little slot there, and tell the ReGuard 7 to upload configuration. And basically now, instead of having to program it at the actual screen, you can actually upload it through a USB. You can create configuration and component reports from the dashboard. You can affect a cause-effect matrix. But what the dashboard cannot do, it can't send text or emails if any of those points go into alarm. It can't do any data logging. There's no web server, so you can't log into the device from somewhere, from wherever you got internet access and be able to see what's going on with your safety system. And you cannot configure the detectors. Like I mentioned, it's a really big selling feature of the ReGuard 7000. You can configure the detectors through the controller. If you have the dashboard version, you can't do that. You have to do that through the other version we'll talk about in a minute. And it's not part of the safety system, a mesh system. It's basically, there's no CPU for that dashboard. So I'll show you what the screen looks like once you actually have a system hooked up and connected. Basically, these are your different channels, channel 102, 103, 104, that you basically have hooked up to it. You can see you got a PR 7000, a Polytron 7000 for O2, a Polytron 7000 for CO. So basically, that's how the screen kind of looks if you're navigating through it, as far as how you make it configure detectors or make changes or whatever you want to do. So next I want to talk about the panel PC option with Vision 7000. So you have two main ways we can visualize the information coming from the ReGuard system. One with a dashboard, which is limited. It's a little less expensive than a panel PC, or we go full on panel PC with all the bells and whistles. And there's not that much price difference, I don't think. So what is a panel PC? Basically, it's a computer that comes with the Vision 7000 and the ReGuard 7000 software, configuration software preloaded onto it. So basically it receives all the data, including the metadata from the ReGuard 7000 safety system. And this is a big feature. It allows for remote service support. As long as the panel PC has internet access, you can allow a support technician to troubleshoot issues and make changes if necessary. So basically imagine a scenario where you've got a ReGuard 7000 system, you're a customer, and you wanted to add an input to it. So if you had the panel PC version with that onboard web server from Vision 7000, you could basically allow a technician in Houston to basically kind of take over your computer and basically be able to get in there through the configuration software and make those changes for you. Or if you had troubleshooting issues or problems with the system, you could have a technician take over. Now, some folks don't feel comfortable with basically us either taking over their computer or having email or authorized access to their safety system. So we developed what's called the DigiBox. It's a little box with a cell phone modem in it. And the customer could purchase that along with a monthly subscription to make sure that or monthly fee to make sure the cell phone is still active. And what they could do with that little box is that when they need to, they could plug that into the ReGuard 7000, right? We could have that technician from Houston dial into that DigiBox, which is connected to the ReGuard 7000 system, troubleshoot, make changes, whatever they got to do to help. And then when we're done doing it, the customer unplugs that DigiBox from the ReGuard 7000 and we're out. So we're in and out as the customer needs us to be versus having all-time access to their safety system. So what is Vision 7000? I've mentioned that a few times. It's basically the HMI software for monitoring the ReGuard 7000. Or basically, we can also use Vision 7000 on Draeger Plus. It's software that's loaded onto the computer that allows you to visualize what's happening with the safety system, and it has a lot more features than just the dashboard. So what can the Vision 7000 provide? Basically, real-time gas concentration values, alarm status, which are the points of an alarm and when they've been an alarm, Data logging, have up to 365-day history of data that you can pull back out of the system to look at through the Vision 7000. And a history data view that you can look at that through the history of it. What can the Vision 7000 do? You can have it set up to send out text or email alerts when any of those points go into alarm. That's a nice feature. So basically, you can basically say, okay, if any of these points go into alarm, I'll set it up that these 3 people actually get an email that the point's going to alarm. It allows you to be able to see what's going on in the system and check what's going on. It's really nice. And also an onboard web server to allow authorized users to remotely log in and view the control system. So let's say that you had a safety system and in Chicago and you're in Atlanta and you're basically the person in charge of that safety system. If you have Vision 7000 on that panel PC that's tied to the ReGuard 7000, you could remotely log in and see what's happening with your safety system. You don't have to actually be in Chicago and actually see what's going on with it. It's a really nice feature for some folks. You can also build a site map with the Vision 7000. So basically you can see the whole site, see where all your detectors are located, and basically see if the points are in alarm and what the current values are via site map. So we also have, we have Vision 7000 software, and we also have ReGuard 7000 configuration software. And basically that just mimics that dashboard. So that screen I showed you guys, what the dashboard looks like with all your different channels, that's all exactly mimicked with the configuration software. So what's nice about the configuration software is configuration can be done offline and then, like I said, uploaded to the ReGuard 7000. So potentially we could either remotely log in to your system to help you troubleshoot, or if we know exactly what the configuration need to be, we can put those on a jump stick and send those to you via mail or email and get those values to you, and you can plug that into the ReGuard 7000. So I mentioned this other software, this Polysoft software. So what does Polysoft really allow you to do? Is a complete integration of the detectors. So anything basically that you can do through the transmitter screens, you can do through Polysoft and more. So for example, you can capture the output. Well, what does that mean, Hillard? Capture the output. So I don't know if you had a customer complain that basically, that's happened sometimes on our ammonia sensors, that basically you got an ammonia sensor out there installed and it may drift a little bit negative, or it may drift a little bit off of 0. And you don't like that. There's probably not gas there. There's just some internal drift in the sensor. That's not actually a situation that you have to be alerted to. So you can actually, through the Polysoft, you can actually up to 5 ppm range around the 0. You can what's called capture the output. And basically say, if you're in any value from -5 to +5, I want you to stay on 0. I don't want you to actually register anything within that range. I want you to stay on 0. So what does a customer like? Customer wants their transmitters to sit on 0 and send 4 milliamps all the time. So that's the way we can do that. We can help them. I think that they set the limit at 5 though, because basically anything above that would probably be a real situation, either positive or negative, that needs to be addressed. But we can help a customer do that. And that's something this customer you can do through Polysoft that you can't do through the transmitter itself. So that's some of the reasons you'd actually want to get Polysoft. So I mentioned Vision 7000 software, and this is basically a screenshot of what it looks like. So basically you can set, I think, one of these screens up to basically have up to 32 inputs on one screen. Of course, you could go through multiple screens if you needed to. But basically, you can see for the first point there, we have a Polytron 8700 reading hexane. So it tells you the gas type, it tells you the value, tells you what the units are, and tells you with these little LEDs, A1, A2, and fault, if since there's currently an A1, A2, or fault, or if it's green and all good. So you can do that for each of the channels. And when you order that panel PC with the Vision 7000 on there, that's part of what the guys in Houston do, is they pre-program these things to show all those different values on the Vision 7000 screen. So you can also have basically like a Scada view, basically a history view of the system. So you can see all the different channels are color coded. You can basically view all the different alarm set points. You can view all the historical data. So basically Vision 7000 almost looks like a Scada system for the customer. So you have event logs, a live alarm panel. You can actually select a date to go back in time to actually look and see what's happening on that particular day. You can do all that through the Vision 7000. That's reading real-time information from the ReGuard 7000 system. Like I mentioned, you can see the time of day, and if you move that bar around, you can actually change the times versus potentially change the values that you're seeing. This is basically the alarm log view. So if you hit the alarm log button on the front screen, it basically will show you the alarm history for all the channel inputs. And you can actually take that and you can actually print it, or you can export that to a CSV file, basically look at it on Excel, all that data. This is basically your alarm set point view. You can look at all the different alarm set points and where they're at. And this is basically what the Regard 7000 controller configuration software looks like. So like I mentioned, you could have a whole project. You could do all the configurations at your home or your office, and you can export those configurations to a USB stick and go to the actual Regard 7000 at the customer site, plug that in, and say upload configurations. So lots of ways we configure this Regard 7000 for the customer. A lot of flexibility there. That's basically what the dashboard view would look like on the Regard 7000. The dashboard looks like. And like I mentioned with the Business 7000, you can also build a site map, like I mentioned. So you can see this kind of one we've done before in the past for a middle school. You see all your different points, see whether an alarm. So you can actually have a more kind of a understanding of where the detectors are in the plant and see what's going off and see what you got to do. So this last screen just talks about the networking capabilities of the of the Regard 7000 through that Modbus TCP/IP output module. So if a customer buys a Regard 7000, most of them will have the Modbus TCP/IP output. Once you've got that output, now you just got to connect to that, and that's basically Ethernet. So basically through a multitude of devices, you can actually hook onto that. I know we're quoting a big project right now for air gas, and that's one of the features that they potentially could like. They're not going to use it right now. Basically, we'll have the controllers have the Modbus TCP output, so that all the different regional managers can potentially log into that individual Regard system to see what's happening with that. So they don't have to be there in front of the screen. They could just do it at their leisure and see what's going on. So you can see what's happening live with all of your points at any Regard system in the world, as long as you have internet access. You can also potentially make changes to that system, either yourself or have a Draeger help you. So how do you configure the Regard 7000? What options are available? One, you can pay Draeger to do it. And we could up front, you would charge up to $200 per point to pre-configure the Regard 7000, or you can basically pay Draeger service to come out after you've purchased the system to come out and actually do the configurations live on site. So I've done it both ways. It depends on what makes sense. Or the customer can configure themselves. If the dashboard version is purchased, then you would actually configure through the dashboard touchscreen. And of course, if the panel PC option is purchased, it will come with the configure software preloaded. And that configuration software basically mimics the functionality of the dashboard. So with the panel PC, you get 3 everywhere server licenses for that PC. So up to 3 different logins that you can have for that panel PC to get into it and make changes. So therefore, you can configure the Regard 7000 from any computer with the configuration software loaded onto it, and then upload the configurations to the Regard 7000. And like I mentioned, it'll be the last control they have to buy, because we can do firmware upgrades on it to make sure it's going to work now and in the future. And that's the Regard 7000 control system. So.
Well, Hillard, thanks for participating and doing this session at the July Central College. We certainly appreciate that.